Hi folks, welcome back to Physics with Captain Rod. I'm helping out here with, again, midterm exam review in hopes of prepping you for your final exam. So question 8 here is about conversions. So make sure when you do these conversions, all right, you write them out. This is what I'm looking for. So I'll walk through this one. All right, so 2,500 watts. Whenever you do a unit conversion, you are always multiplying by a fraction. And the fraction needs to leave you with what you want and cancel what you want gone. So here we want watts gone, so the watts has to be in the bottom, and we want to be left with horsepower, so horsepower up top. Then you look for your conversion factor. There's 746 of these in one of these. And then 2,500 times 1 divided by 746, that is some number now in horsepower. So make sure that you write those out for the rest of these, and I see that I have answers here for some of these for you too, so you'll know if you're doing it right. Oh, let me chat about this one just a little bit more. So this one's got a couple things going on. 90 mile per hour. So this has two things that have to be changed. The mile we want to meters, and the hour to seconds. So let's take them one at a time. To get the miles into meters, your conversion factor has to have miles on the bottom so that they cancel, and meters up top. And then you look up your conversion factor. There's 1,609 meters in 1 mile. I would not expect you to memorize that. Probably that's sitting up here somewhere. I'm just double checking. Yeah. Right. Then, to get rid of the hours, our next conversion factor has to have hours up top, seconds in the bottom. And there's 3,600 seconds in 1 hour. If you don't realize that, you could do hours to minutes, and then another one for minutes to seconds would work just fine. And again, the important thing to recognize is, your miles cancel, your hours cancel, leaving you with meter per second. Biker at an unknown speed, known with an N there. I'll have to change that in the future. So basically the biker's moving here with some speed that we do not know, so label it. And then she ends up, that's going to be my quick bike here. There's the biker at position 2, with the height increasing by 25 meters. Now it's important to realize that she stops pedaling right here. This is a coasting process. And what that means is there's no extra energy input. This is just kinetic energy to potential energy. So you write out the work energy theorem, and I want to see you write this out when you take that exam. Your final exam I'm referring to. Position 1 is the lowest point position. We can call that potential energy 0. Ooh, pardon me. Got one more coming here. Nope. All right. KE1 is our kinetic energy at 1, so you write 1/2 mv squared, or v1 squared. Work again is 0. That's the part where she's not pedaling. If she were pedaling, there would be a work term that would be increasing her energy, but that's not the case in this problem. Again, most of the problems I give you in this regard will have works of 0. PE2 is the MGH, right? And this is our H. And at the highest point, she's not moving anymore, right? She's stopped, so the kinetic energy is 0. And then, if we write it without the zeros, and you'll notice these masses now cancel. So the G is the 9.8 meter per second. The H is the 25 meters in this problem. You multiply by 2, solve for V. So make sure when you write any work energy equations or you use principles of energy, you are 1, drawing a picture, 2, writing this out, and then 3. These are the things I'm going to look for very carefully when I grade that exam. Whether or not you get the right answer or not is not super important for me. This is probably the most important line right there, this. That's what I'm going to mainly be looking at. Okay, number 10, let's see. A car starts from rest. The driver hits the gas and accelerates the car to 25 meters per second in 12 seconds. All right, so draw a velocity graph. Car starts from rest. So at t equals 0, velocity is 0. 12 seconds later, 25 meters per second. So 12, 25 meters per second. And we'll assume constant acceleration, which means connect them with a line. All right, the how far. Okay, that's going to be found from this area right here. Right, that's a triangular area, so the delta x is going to be 1/2, in this case 12 seconds times the height, 25 meters per second, and you're going to get a number. Acceleration, right? Just have to know how that's calculated. Change in velocity over change in time. That's slope, rise over run. In this example, 25 meters per second over 12 seconds. And you're going to get a number with units of meter per second per seconds. Well, I guess that's it. Okay, so there's the rest of it. I'll be making another video here to help you out with the circuit problems and the magnetism and stuff. So good luck studying for your final exam. Text me if you need anything.